So far we've used the log properties to take log expressions and spread them out. Okay, so now let's go use them and go back the other way. So I just have two problems written up here. Something very important to note when we're doing this is notice these bases are all the same, right? We can only do it if the bases are the same. If the bases are different, we'd have to separate them out. So again, the log property only applies to a common base. So when you see adding, that's the same as multiplying here. Subtracting means we're going to be dividing here and dividing here. So we can take all four terms and combine them into one, and it's going to be log base 3 of, so x times y, this is divide by m and divide by n. So divide by m and divide by n. And don't let it bother you that those are being multiplied. The fact is the m and the n are both in the denominator, and that's what we're really saying when we talk about that subtraction there. So we've taken this whole thing and compressed it right down into that. So now this one here is a little messier, but again, notice our bases are all the same. So let's use the exponent rule first. You can see this can come here. This is a times the log, so a can come become an exponent. The b can become an exponent, and the 4 here can become an exponent. So let's just rewrite that with those changes. So I have log base 3 of x to the 5th minus log base 3 of y to the a power minus log base 3 of m raised to the power of b. And then I have log base 3 of n to the 4th. So just like before, so now this is subtraction, so this will be divide. Subtraction is divide. And here we have addition, so this is going to be multiplication. If it helps you, you could think about that as being plus as well. So now we're going to have log base 3 of, and what's in the denominator? The things we're dividing by. Y raised to the power of a, m raised to the power of b. And in our numerator, we're going to have the x to the 5th power times n to the 4th power. So let me get you a couple more examples, and we'll wrap this up. Okay. So this looks very similar to before, but notice those are 2's and those are 3's. So what we should do really is just reorganize this. So I have log base 3 of x minus log base 3 of n. So I'm just going to group these together. And then over here I have my log base 2 of y minus my log base 2 of m. All right, now I can rewrite this as log base 3, and that subtraction means to divide. So this is going to be simply x divided by n. And here I have log base 2. And again, this is divide. So this will be y divided by m. But since these are different bases, we can't combine those. Now how about this one? How many of you are tempted to do this? Log base 3 of m times log base 3 of 2n. Anyone tempted to do that? So this is not correct. This one you can't actually do anything to. It's fine the way it is. So addition would be like here, where we can take two logs and combine them into one, into multiplication, right? But this is saying log of the entire thing. So let me give you an example of when we could actually do something with that. So here I have log base 3 of this, and they're exactly the same, right? So I could rewrite this then as a log base 3, so this is addition says to multiply, and you multiply the argument, so this would be m plus 2n times m plus 2n, which would be nicer to write it as log base 3 m plus 2n squared. And that's fine, you could move the 2 in front, but I don't know if there's any advantage to doing it that way. All right, so I do have one last example here to show you. Let me just erase a little bit of the board here. This one here is if we know the value of a certain log, how can we use it to help us find our solutions? So let's try this. Let's say that you know, without your calculator, you know that log base 3 of 2 is 0.6309. So this is just some given information for you. Now let's say they ask us to find log base 3 of 8. It's not helpful right away, but think about 8. 8 can be factored into 2 cubed, right? So I can rewrite this as log base 3 of 2 raised to the power of 3. All right. And using our log properties, then we know that can come out front. So this could be then 3 times the log base 3 of 2. But we know log base 3 of 2 is that. So then this is 3 times 0.6309. So that's going to give us then 2.5236. So that would be our answer from that. So again, what we're starting off with is we're given a certain value for log base 3 of 2. All right, so that should wrap it up. Hope it goes well for you.